webinar on package integrity testing. I'm Greg Hammer, and I'll be your moderator and webinar organizer today. Before we get started, let's take a moment to ensure that everybody is ready and familiar with the webinar control panel. First, you should have a control panel on the right side of your screen. You may minimize this panel by clicking on the orange arrow button in the upper left-hand corner. You may expand the panel by clicking on the same button. Second, you have the ability to submit questions using the chat pane located near the bottom of the control panel. We will be answering a few questions during the webinar. If we can't get to all the questions during the webinar, someone from Westpak will follow up with you after the webinar. We will also be using the question asking tool during this webinar. Please raise your hands so we can make sure that this tool works. Okay, let's get started. Today's presenters are Herb Schoenemann and Edmund Tang. You may remember Herb from the last webinar on package integrity testing versus package performance testing. Edmund Tang is a lab manager here at Westpak and has been with us for 9 years. He also enjoys teaching at San Jose State University. Herb, take it away.
Okay, thanks a lot, Greg. I appreciate the introduction there. As Greg mentioned, I'm Herb Schoenemann, the President and CEO of Westpak Incorporated. Westpak is a testing laboratory, a series of laboratories in California, and I've been involved in packaging for a long time, as you can tell from all the gray hairs and wrinkles. What we're going to talk about today is package integrity testing. And I'm going to try to define that for you, and then define the purposes of the testing, and then how it's done, and how you can tell when a good job has been done. So this is kind of an overview of what we're going to be talking about for the next 45 minutes or so to allow people for questions. We're going to first of all define product characteristics from a packaging viewpoint, because that determines how we're going to test it. We're going to review the functions of a package very briefly, and then we're going to look at the package design function for what I'm going to call a qualitative environment, which is what we're talking about during this webinar. We'll carry that forward and then tell you how to test product package systems in a qualitative environment. We'll cover things like the critical elements, sample size, test sequence, and things like that. And then we'll end with a final evaluation. When do we know we've done the job right? What are the clues that we can bring to the boss and say, hey, this job is cool, no problem. First of all, then, from a product characteristics standpoint, I'm going to want to know whether or not I can measure some things during the test of the product and package system, and whether I can test, whether I can measure or not determines the type of test that I'm going to do. So I broke these products down into what I'm going to call Type A and Type B. And Type A are going to be suitable for a quantitative analysis, in other words, measurements, accelerometers typically, and then B type, which are suitable for qualitative analysis. Can't put an accelerometer on a can of soup, or at least within the soup, very easily. So first of all, is the product breakable, or is it impact sensitive? Yes or no. A products are the electronic type, let's say, and they are very breakable. So they're impact sensitive. We can measure that. Temperature sensitivity. So these sensitivities are what is likely to occur in distribution when we ship it, when the package must do its job. So you can see that in some cases the A-type products, the quantitative analysis products, differ from the qualitative ones. Last month we covered package testing procedures for Type A or quantitative analysis products. So if you have any questions about that, I would refer you to our website, where that webinar is recorded, if you're interested in sitting through an hour of me talking. There's also the slide stack if you want to do a Cliff Note version of that. This seminar then is going to be dedicated to what I call package integrity testing, and I use that term very precisely, very definitively, integrity testing as opposed to performance testing, because integrity means in my opinion, that it's a qualitative test. You can't really measure the results except by the end result itself. So here's some characteristics of these kind of products. I call them B-type products, but think of them as qualitatively analyzed product package systems in terms of impact sensitivity, temperature sensitivity, altitude, compression, ozone, sterility, those kind of things. So there's a reasonably good list if you want to review that in the future. There's another way to think of it. These so-called A products, or the quantitative ones, can be evaluated using numerical analysis. They can and should be handled according to the performance design procedure that I mentioned earlier. And again, go to our webinar to refresh your memory and your anxious moments about that one. The B products can't be evaluated or tested quantitatively. They must be handled in a qualitative manner, without numbers, without instruments, if you will. So that's what we're going to be talking about today, and that's what I call package integrity testing, and that's the subject of today's webinar. Okay. So with that as an introduction, I'm going to hand it over to my good friend and colleague, Edmund Tang. Edmund, take it away.
Thank you, Herb. So as Greg and Herb previously said, I've been at Westpak for almost 9 years now, and I'm a lab manager there. But also, in addition to that, I'm also a teacher at San Luis State, and I teach the packaging dynamics course and the supply chain course. But okay, so before we get into the meat and potatoes of this presentation here, let's go over a little background of functions of a package. So packaging can serve many functions, but just in general, you want to hit maybe 2 or 3, the more or better functions of a package, but bare minimum, you need to hit at least one of them. And if you don't hit at least one of these functions, then you probably have some reconsidering to do. So the 6 functions of the package that we're going to go with today is, first one is preservation, protection. Second one is containment, followed by sell the product and give the consumers a motivation to buy the product. Convenience, ease of transport, stacking and storage, followed by printed information. So let's get into detail for each of these functions here. So for the first function, preservation and protection of the product. And that's pretty much to protect your product from being breached and contaminated. And if you think about it, this relates more to the food and medical device industry because, once your package is breached, the whole integrity of the product is in jeopardy. So let's just take, for example, your juicy steak that you buy in the local, supermarket. And typically, it's wrapped with a polyfilm, and then you take it home and you put it in your refrigerator. And it could probably last maybe, 2 weeks or something. But let's just say when you put it in your refrigerator, something stabs it and it gets breached. So, even though it's in the refrigerator, it could probably only last less than a week because now microbes are exposed to it and it's getting oxidized. And you look at medical devices as well. So most medical devices, you think, they go into the human body or they do something with the human body. Therefore, it's a medical device. And then what's the most important there is that before it touches the human body, it needs to be completely sterile. And once that gets breached, you have the risk of running contamination. And then when you have contamination, you have the risk of running infections. And then, worst case scenarios that when you have infections, you might, have a death of a person. That's worst case scenario. And here's a little fun fact for you is that more than 30% of global food production is wasted due to improper packaging. So you could see that the preservation function is very, very prominent and very, very important. The second function of the package that I'm going to go through is to pretty much contain the product to prevent spillage and loss. Many products, you think about it, it's pretty impossible to hold without a package or without a container of some sort. So you think of, the first category, which is liquids. You could probably take some water from point A to point B, but, with your hands, you probably end up with a few drops by the end of the trip, if at that. But then, you take it with a cup or you take it with a drum or you take it with a can or anything. And point A to point B, you probably have 100% of your product still there. And that's where the package comes in to contain the liquids. And then it doesn't only deal with liquids. It also deals with small items such as cans of corns, jars of pickles. Like, you could hold, like I said, corn in your hand, but at the same time, how much are you going to lose when you finish your distribution cycle? And this is a second function of a package. The third function of a package is to sell the product and to inform the consumer what the product is. So the package is oftentimes, most times, the first point of sales of the product. When you're walking through, when you're walking through a store, you look at a package, and then, if you're quote unquote health savvy or health conscious, you're going to look at something that has one, less calories, or low fat, maybe maybe organic, and something like that. So, but you think about it in the, maybe 10, 20 years ago when Apple and Macs weren't as prominent, and then you would go through the software shelf and you would look for one sign that says Mac compatible, and then that will, scream out at you in the package, and okay, I could use this product for my Mac that I have that's not as popular as a PC. And then also what it has is product warnings as well. Like you think about, just rat poison or something like that. It usually has a toxic sign. Maybe it's in yellow and red or yellow and black or something. But it screams out at you and says, hey, there's something you need to be worried about with this package. So, if you do buy this package, make sure you keep it on the top shelf or something so your pets or your children don't get handled with it. So product warnings, and also to sell the product and to inform the consumer what the product is. The next product and package function is to protect the product during transportation and ease of transportation. So in general, everything is fragile to some extent, and if you ship something through the distribution environment by itself, bare product, I could almost guarantee that you will see damages. So that's where the package comes in, to actually help protect your product so it survives the distribution environment. And the second function of this function is ease of transport. So you think of, just holding 12 cans of soda. You could probably do it with your hands without a carton. It'll be a pretty big feat, but it's probably doable. But at the same time, you put your 12 cans of soda into a carton, and guess what? You could hold 12 cans of soda per hand, which will give you 24 cans of soda. And, further thinking about this, if you throw 24 cartons of 12 cans each into a pallet, you can now carry 288 cans with a pallet jack or with a forklift. So ease of transportation there. The next packaging function is stacking and storage. So a lot of products by itself, it's either one, impossible to stack stuff on there, or two, it's fragile when you stack things on there. So let's just take, for example, liquids. Typically you can't stack anything in liquids because if you put anything in a liquid, it's going to just disperse. But if you put it in a can that has stacking strength, now you could stack drums and drums on top of each other, and one, save a lot of space and also contain the product. But you also think of other products such as solar panels or something made of glass. You could probably put maybe 100 pounds on there or so, depending on the compression strength of your product. But after that, you really, really run the risk of popping your glass or shattering everything altogether. And the package actually gives your product a little more compression strength, so you could go ahead and stack more units on top of your units. And this will reduce your space in the distribution environment and the warehousing and in the supply chain. So the last packaging function is printed information. And this is additional information for the consumers. And at this point, you're actually on the verge of buying the product, and you picked it up already, and you're reading the nitty-gritties now. And it says, okay, this is my first time working with an egg. Okay, let's see what I could cook with an egg. And then they might give you a recipe or something like that, or there might be a code that you can scan to look up online. Or like I said, with the software, you could look at the compatibilities. Hey, is this compatible with Windows 7, Windows 8, or is this compatible with the Mac? And it also gives you just the nitty-gritties, instructions, and safety concerns on the package as well. And this is just a general overview of the 6 packaging functions, and Herb will take it over from here.
Okay, Edmund, thank you very much. I was impressed during Edmund's introductory remarks there that for identification of the product, for example, when I first studied this process about way too many years ago, it was estimated that about 25% of the products that you encountered in a typical market, you could see or touch the actual product itself. The latest study that I read reduced that number to about 8%. So what you see when you buy things in a market is not the product. It's the package. The package has the major portion of the communication responsibilities. And this is what I am, this is who I am, and this is why you would like to have me, type of thing. Interesting. Good job, Edmund. So, okay, what does this all mean? Well, basically, when you design a package, it must account for the product sensitivities, and that's really what we're trying to talk about, that are likely or even possible when you distribute the product. We know intuitively that this is where the package must do its job, so we're going to have a good understanding of these things in order to do a reasonable job of the package design. Okay, now I got to design a package for this product. How do I do this? Well, you make certain that the test of the product package system in the laboratory, first of all, is a very good representation of the actual shipping environment, because this is the crux. This is the bar over which the product package system must go in order to be considered good, successful. So you got to have a goal, first of all, and the goal is a very good procedure whereby you have an accurate representation of the environment in the laboratory. So you know you've done the job right. Then what you do is for each of the product sensitivities that you have identified from that list, determine the best material fabrication or process that does the job the best. And for each of these materials especially, you have to make sure that the material is readily available. You can't specify something that's rare and found only in Afghanistan, for example. Compatible with the product, very important, especially with consumer products. Compatible with the end-use environment. Once the product package system arrives where it's going to be, it should be compatible. You shouldn't contaminate the environment just because it has a package on it. And of course, environmentally sound. Now notice I've used the word environment twice there. I've used it in terms of the end-use environment and then environmentally sound. The word environment has kind of gotten stolen away, if you will, over the past 20 or 30 years to mean things that are ecologically sound. And we've used the term environmentally sound to equal ecologically sound, and I'm using it in that same tone. So when I say it's compatible with the end-use environment, think of it as the end-use place or location, and then environmentally sound, think of it as being ecologically sound. And again, I apologize that those terms have kind of merged over the years. I don't really control the language. I just try to use it like most of us. Here's how I like to think about that package design process. If you sit down and most of you had to do this or have been involved in the process, you have to take each of these requirements of the package, if you will, most of which we've gone over, and somehow those have to be incorporated into the package design itself. These requirements of the product. It's different for every product. At least I found it to be different. So there's no one cookbook formula that says here's how you design a package for a consumer product, for example. Most of them are dictated by a bunch of different organizations, requirements. Marketing has a big input into it. Legal has a big input. But somehow you have to account for all of these particular things or functions that the package must do in order to properly protect the product. The protection and the motivation, identity, safety, legal, all that kind of stuff. Sterility if you have a medical or pharmaceutical product. When I was going through college, there was four items that a package had to do. It was the functions of the package were protection, convenience, utility, and motivation. And I'll tell you that was drilled into us, and we had it on every exam. But you can see that the list has expanded over the years, and probably rightly so. We were a little simplistic in the 60s. So what does that mean for what I refer to as a B-type product, where qualitative analysis is involved in the process? Well, here's some examples. If your product has a moisture sensitivity, then you're probably going to want to use a film or a barrier of some sort. And I just use nylon or polyamide film as an example. It's a very good moisture barrier. If you have a sterility issue with the product, you might want to use a porous material. A Tyvek or spun bond polyolefin is a good choice because you can use a variety of different sterility or sterilization techniques such as ethylene oxide gas and a few others. The convenience function, well, you might put it in a thermoform tray of some sort. Protection or the stackability function, corrugated shipper is typically used for that. Probably the most common packaging material ever. For the communications functions, you might have an inner carton with labels on it, for example. Utility function might be handholds on the product to assist in the manual handling, and so on. The point is that each package function has its own identified material, element, or component. Okay. The final design of that B-type package brings all of these elements together, as the graphic on the previous slide showed, into a workable and functional system. And the purpose is to deliver safely that product to any place in the world in an efficient manner. Okay, so now that we've got that function, those functions identified, okay, now we got to test. We got to say, did we do the job right? Is this thing really going to work? Okay, you've got to be able to go into the boss's office and say, yes, boss, this is going to work, and I tested it. So Edmund's going to tell us how in the world we do that. So Edmund, it's all yours.
Thank you, Herb. So as the question that Herb just asked, how do you tell your boss, or what do you tell your boss, how will your packaged product fare during the distribution environment? This is the $1 million question. If you're going to answer this every single time, and every single time accurately, you have many, many troubles solved for you. But before we answer this question, let's give some more backgrounds of packaging cases and for the product. So very, very common is for packaging cases. If you look on this chart here, you see a black bar that says environmental severity. Environmental severity is pretty much everything in the distribution environment that your product and your package will encounter from point A to point B. So in general, the green bar is your product fragility or your product robustness. By itself, if you ship your product through the distribution environment, it probably won't survive. You ship a computer, you will have damage. You ship a cup, it will break. You ship a block of wood, okay, maybe it might survive, but then how often do you ship a block of wood? So with the first packaging case, you have your product, and let's just say it's a computer, and then you have some foam, and you have a box in there to supplement for the additional environmental severity that your product cannot survive. And at the end of that, it survives, and that's just pretty much its original packaging. The second case is when you underestimate your distribution environment, and you think that, okay, maybe, my product won't see this during the distribution environment. Maybe it's only going to be dropped from 10 inches. So I'm going to design my package according to 10-inch drops. And then what you find out is that it's underpackaged. And with that case, you're going to have product damage. The third case is that you overestimate your environmental severity and your distribution environment, and then you actually have more packaging than you need. And with this case, you waste money in materials, but you also waste money with the supply chain, because with that, you could fit less units per pallet, and then you need more pallets, and you need more trucks, and so on. And the fourth case is product improvements. So with product improvements, not only do you have a better product for your consumer, but you also save money with materials costs, and you save money with supply chain costs because you reduce your overall cube and you increase your cube efficiency. And with that, you ask yourself, okay, I've been talking a lot about the distribution environment. Okay, so what's the distribution environment? How do we measure the distribution environment? What many of you guys might be asking now. And what factors are we concerned with? What tools do we have at our disposal? And can we leverage existing data, because right now we can't map our distribution environment? So all these questions will be answered within the next slides. So the first question is, how do we measure the distribution environment? And to properly measure anyone's distribution environment is that you have to subject the package system to a distribution cycle that is a representative of what the package will normally experience during transportation. So what that means is that if your package originates in China, you have to start your distribution study in China. There's no reason why you would start your distribution study in US, because it just doesn't make sense. That's not your cycle. And then from there, you would record every single event in the distribution cycle that may affect package integrity. So when you think about that, package integrity, okay, what affects package integrity, and what factors are we concerned with, and what can we record? And some of the factors that we can record and affects package integrity is impacts, drops, vibration, temperature, humidity, and pressure, altitude. At the same time, some people might not even be concerned about a lot of these test inputs or inputs in general. Like, for instance, if you're shipping a box of clothes, okay, are you really concerned with impacts and drops? Probably not, because your clothes can't break. Vibration? Probably not that much either. Temperature, humidity? Oh yes, you will be concerned with that, because if your fabric gets wet or it gets overheated or cooled, it might affect the properties of that. And pressure? Okay, maybe not, probably not. But at the same time, if you look at something like a computer, are you affected by impacts and drops? Yes, definitely. Vibration? Definitely. Temperature, humidity? Okay, not so much. Pressure? Not at all. So here's two examples of just different products that are concerned with different inputs. So now you ask, okay, what tools are available? How do we map this? And typically, the distribution environment is measured with field data recorders that records every single potentially hazardous event that occurs during distribution. And also, these tools will timestamp each occurrence, so therefore each specific event can be mapped to a certain time during distribution. So if you map your distribution cycle, distribution environment, and then for some reason you find out, hey, for the first 12 hours, they're having like many drops and many vibrations, and what's going on there? And either one, you're going to investigate it, or two, you're going to actually design your package to make up for those, to protect against those 12 hours of really vigorous handling. And then if you look in this picture here, the distribution environment field data recorder there's a picture on there, and it's a pretty small unit. It's probably maybe 3 inches by 4 inches by 2 inches. So it's definitely mountable to a lot of applications here. And then now, many of you guys are probably thinking, wow, that sounds like a lot of work. Is there any, pre-existing data that we could leverage, because I don't really have time to map my whole distribution environment. And then what we tell everybody is yes and no. So let's go over the yes first. So with yes, there's many published studies that are widely available on the internet that record specific routes of travel. So, you just do a search and say, distribution study, and you probably get something. But at the same time, I also say no, because anything you find online, it's someone else's distribution study, and is it your distribution cycle? Probably not, because every product's distribution environment will probably be different and unique to a specific route depending on where the product originates and the path it takes to get to the final destination. So, so I would like to tell everybody, actually, no, you can't leverage stuff, but there's stuff available, or there's studies available. And here's a study that was done recently, which is called the MADE study. And MADE stood for Measurement and Analysis of the Distribution Environment. And the MADE study's main focus was to revalidate previously measured drop data. So back in the, I don't know when, but probably back in the early 90s or late 90s, there were some studies, and they said, okay, we measured the distribution environment, and we're going to have this many drops and from this many drop heights. And then what the MADE study did was pretty much say, hey, okay, now we have, technology's better, and we're more knowledgeable than before. And let's see if the previous drop data held true. And the setup was that they mounted field data recorders on wood blocks in a package and sent around the world to represent a 24-pound box to simulate a computer. And the results was that the drop height found in all 6 round trips was 58 inches for the highest drop height, and it was only 1 occurrence. And then there was also very few drops over 36 inches, which is actually less than 1.5% approximately. And there was very few drops over 14 inches, which is actually less than 5%. So next we have a distribution graph from the MADE study of the drop heights and the number of occurrences. So if you look at all the way on the right side, you see 1 58-inch drop. And then if you look, you go to the left even more, you see 36 inches, and you see that there's very few drops over 36 inches. And then you go to another statistics that I showed, which is 14 inches, and there's even fewer, not even fewer, but there's only less than 5% drops under 14 inches. And if you look at it, most drops were between 2 inches, 4 inches, 6 inches, and 8 inches. So keep that in mind as we talk about this next topic. So with this next topic, I'm going to go over 2 very widely used test standards, which is ASTM D4169 and ISTA. So with a 25-pound box, if you were to test it to ASTM D4169 at assurance level 1, which is the most severe, we're going to have 11 drops at 21 inches and 1 drop at 42 inches. If you were to test to ISTA, you're going to have 10 drops at 32 inches. So the statistics that I just showed you before was that, okay, there's actually only, less than 1.5% of the drops that are over 36 inches. So why, are we testing at such high levels here with ISTA 2A and ASTM D4169? So, a lot of people are like, hey, oh yeah, might be a little confused now, might be a little angry, is ASTM D4169 and ISTA 2A, are they just over-testing our packages? So are we, over-packaging our products here? And that's going to be answered in the next slides as well. So typically, test standards such as ASTM D4169 and ISTA 2A will be more vigorous tests than what a package will experience in the distribution environment. And the reason for that is 3 reasons. And the first reason is for the acceleration factor. For the acceleration factor, what we mean is that we amplify test inputs to build a level of confidence in the packaging and accelerate testing. So whenever you take a package into a test lab and you try to, quote unquote, simulate it, the distribution environment, you're going to be done with your testing within 4 or 5 hours. And then you ask yourself, okay, so, but how long is your actual distribution cycle? It's probably maybe 2 or 3 days. So you're bringing that much time into a matter of hours, which accelerates testing. And the second reason is because of the sample size or lack of thereof. So you think about if you ship, let's just say if you ship a computer, how many do you sell? You probably sell maybe 1 million of them, 500,000 to 3 million if they're popular. And then how much do you test in the lab? How many do you test in the lab? Maybe 1, maybe 2, maybe 3. But then the 3 is supposed to represent every single unit that you sell for your company. So you think, so with that, because we have a lack of sample size, we have to test with something with a test factor that is, quote unquote, over the distribution environment. And then the last reason is to shorten the test, which is actually very similar to the acceleration factors. So we're amplifying test inputs to build a level of confidence and also put your 3-day distribution cycle into a matter of hours here. But what we like to tell everybody here is common sense goes a long way. So when you ask, when you design your package to your distribution environment, you just think about what your package or what your product will be subjected to. And here's an example. That if you have a pallet that will always be palletized or a package system that will always be palletized, it'll never leave the pallet, should you subject your palletized package system to free-fall drops? And then you think about it, and it says the only reason why it's ever going to be free-fall dropped is if you handle it with a crane. And then if it doesn't get dropped from a crane, it probably got dropped off the truck. And then if you design your package according to that, then you're designing your package for abuse and not really for, quote unquote, real world and distribution environment standards. So the answer we give is no. If your system will always be on a pallet and never handled by a crane, then why should you subject them to free-fall drops? And then, like I said, yes, if your palletized package system will be handled with a crane. But even then, maybe 12-inch drop height should be the maximum just because cranes don't impact your units from that high as a single parcel. But like I said, remember, all distribution cycles are unique to its transportation route and should be tailored accordingly. So here's just some pictures of what a distribution cycle looks like in the real world. So, and before I go over this, actually, it looks like there's a question from the audience that Greg wants to ask. So let's hear it.
Edwin, we don't have any questions right now, but we just wanted to remind everybody you do have the ability to ask questions throughout this webinar. So if something pops up in your head, go ahead and send it in, and we'll break into the webinar to ask the questions. So just as a reminder, go ahead and use the chat pane. We'll break in when we can. So thanks for the interruption, Edwin.
Thanks for the reminder, Greg. I was wondering if there was any questions, and thanks for the encouragement as well. So with these pictures, so your package or your product might originate from different environmental conditions, and you think of it, not everything originates from a sunny area. Some might be very hot, maybe humid, and just very rainy, so we have different environmental conditions. And then when you drop off your package, you probably won't really give your package any drops or impacts, but once you drop it off and once it's placed in the sorter, all bets are off. It's probably be banged and handled by the local delivery people as willing as they want. And following back that, your package might be stacked because when your package is in the truck, there's no guarantee that your package will be on the top. Sometimes it's on the bottom, sometimes it's in the middle, and sometimes it's on top. But you need to actually design your package to withstand some top load. Following that, A package might be shipped via air, but I guarantee you it'll be shipped via truck, because the truck is always the final leg of the supply chain, because everywhere it goes, all products go through truck. And then finally, the package is delivered. And this is, quote unquote, what a real world distribution cycle looks like. So if you were to take this cycle into the lab, what will it look like? And here's what it will look like in the lab. So for the different environmental conditions, we'll put the packages in a chamber, and it will go through your hot and humid, freezing, maybe rainy and humid. And then initial manual handling is when your product and package is dropped off, and it's in the UPS sorter, and it's being banged and handled and manhandled. Next is vehicle stacking. Like, for instance, your box might be on the bottom of the stack, or someone might actually find your box very, very convenient to step on to reach something, and then so you actually have some stacking there as well, followed by vehicle vibration and loose load vibration, which will be either truck, air, or both, and then followed by final manual handling, which is the final leg before your package gets delivered to the final end user. And this is Herb to clean up and finish the presentation.
Thanks, Edmund. That was an excellent review of the process of bringing the distribution environment into the laboratory, and that's an important concept to remember. The whole purpose of testing facilities such as Westpak, we're not the only one, but our purpose in life is to actually bring that distribution environment, the hazards of that environment, into the laboratory to subject your product package system to those hazards in the same sequence as they would experience in the distribution environment, and then to evaluate the results. Now, the severity of that input, as Edmund pointed out, is likely to be higher than the mean level of the distribution environment. In fact, we want it to be higher. We're actually targeting the 3 sigma level. In other words, we want to encompass 99.4% of all of those potential hazards in the distribution environment if we can. And that's the whole purpose of this accelerated or somewhat more exaggerated type of testing that we do. I often look at a vibration machine in the laboratory and think, man, if I was on a truck like that, my kidneys would have failed a long time ago. However, that's the whole purpose of it. So thank you very much, Edmund, for giving us a good review of that process. So now we have a product package system for what we refer to as B-type, or qualitative product, one that we can't measure quantitatively. We've designed the package for that after we've considered the functions of the package and the distribution environment hazards through which it's going to go. And then we've designed the test. And so we've then put the product package system through that test in the laboratory. Now what we have to find out is, did it do its job? Did it work? Is it successful? Remember, we don't have any numbers here to answer that question. So we need some evaluation process, something to say yes or no, up or down, good or bad. So successful test defines obviously on how one defines success. And I said that, hey, this is really a nature of the product itself. In general, we want the product to arrive in the customer's location exactly in the condition that is appropriate for that product. And the reason I didn't say no damage is that some products can be damaged. I bought a candy bar yesterday, and the darn thing was broken in half. So was the product damaged? Yeah, it was. Did it bother me? Not a bit, because it tastes just as good. In fact, I didn't have to break it in the car. It was already broken. So some products can tolerate rather a defined amount of damage, and I mentioned the broken candy bar. It's product specific, so you have to define your criteria before you actually do this evaluation. Let me give you an example of what I'm talking about, and I want to emphasize that these are my evaluations, not an industry evaluation or anything like that. Medical devices and pharmaceuticals generally target 0 damage. They don't want any damage, and I can understand that, and I agree with it. I think that's appropriate. Prepared food products, you can have some level of damage, and you're probably going to be more cost efficient with that damage, as long as it's not, potentially dangerous to consumers. Edmund mentioned contamination of food products, and clearly that's inappropriate and unnecessary, and probably not even tolerable. However, if you're shipping household cleansing products, you can tolerate some level of damage. Over-the-counter drugs and medical supplies, a small amount might be tolerable. Industrial bagged products, if you're shipping bagged cement, for example. I picked up many bags of cement in the local hardware store. Darn things are leaking. I didn't return it because I didn't consider it damaged. I was just a little miffed, not bad. Actually, a while back, a study that I'd read said that furniture products can oftentimes withstand or be subjected to or wind up with up to 10% damage in shipment. I was amazed by that, but that's apparently it's fairly common. Probably not very desirable, but fairly common. So again, the evaluation of good or bad at the end of the test depends largely on the product itself. So keep that in mind. Okay. Also keep in mind that this is a qualitative test, so the evaluation is pass or fail. It's thumbs up or thumbs down. And by that I mean we really don't have any margin analysis. You don't have a target value of 75 and an actual value of 85 or something like that. There aren't any numbers, so you can't do any what I refer to as margin or headspace analysis. Your product may be overpackaged, perhaps grossly so. Remember that slide that Edmund showed us that had those 4 cases of packaging, and case number 3 was what he called overpackaging, where the package is too much, if you will, or offers more protection than what the product needs in the defined environment. This winds up being the most severe problem as far as packaging is concerned, because we don't really know if our package is over-designed for the product unless we do an incredible amount of testing. So that's one of the drawbacks of the qualitative procedure, this package integrity testing that I'm talking about here. It doesn't really give you a margin analysis, so you might just very well be overpackaged. In fact, the people who write about this and offer an opinion will often tell us that in developed countries, most products are grossly overpackaged. And every time I walk through the grocery store, I tend to agree with that. The test requires a valid sample size because you have to draw statistical inferences from the whole thing. It also requires, as Edmund pointed out, accurate simulation of the distribution environment in the laboratory. You've got to be able to do that job correctly. And that's why he said, can you leverage existing data? He said yes and no. Well, that's a heck of an answer, isn't it? But it's actually true. You have to do a really good job of evaluating the test procedures and do they adequately simulate the distribution environment, because without that, your test is it's not meaningless, but it's not as good as it could be, that's for sure. Also, remember, for some devices, I'm going to pick on medical devices here, after the package is tested, you can do what's referred to as a post-test morphology. Anyone know what morphology is? I often ask that question, and I remember one student said, it's a study of morphs, of course. Well, no, it's actually the evaluation procedure, and it's required to help guarantee successful results. For example, in medical devices, we might do a burst test on a package after it's been through the distribution cycle in the laboratory, and it might be able to give you a pretty good idea of the residual strength. So it's an effort to say, how much do I have left, almost like a margin analysis. In addition, a peel test will tell you if there's any gross effect on the ability to separate 2 separate pieces of material forming a pouch. Bubble leak check might be able to tell you if there are any breaches in the microbial path, or actually the microbial barrier of the package system through which bugs can travel, but they're not really apparent. You might look at it with your eyeball and say, it looks good to me, but the bubble leak test is a little more evaluation. It's a better evaluation of the package. And the dye penetration test will often look for inclusions, or so-called pass the seal. So these are examples of what I refer to as post-test morphology, where you can actually figure out in means other than thumbs up or thumbs down, do you have a good result here? Those of you in medical device testing will recognize those procedures as coming from ISO 11607. Again, the final test requires the accurate and adequate documentation to prove successful results. Remember, there's no numbers here, so the report winds up being the document by which you can prove successful completion of this procedure and therefore an adequate package design process. Finally, I'd like to point out that about 80% of the packaging dollar, if I can use that term, is devoted to products that will benefit from this package integrity test procedure. In other words, about 80% of the packaging effort can be evaluated in a qualitative manner as opposed to a quantitative manner. Winds up being far bigger than any other kinds of the evaluation technique in the packaging testing area. These tests are the most frequently conducted type of test procedures and evaluation. Edmund mentioned a couple of them. ASTM, that stands for American Society of Testing and Materials. D as in dog, 4169, very popular procedure, came in the 1980s, and again it was an attempt to bring that distribution environment into the laboratory. Those of you familiar with that procedure know that there are, 19 different distribution cycles, and the reason for those is that those are common routines that resulted from measuring the distribution environment. And also, the other procedure he mentioned is ISTA, International Safe Transit Association. 2A, they have about 25 or 30 different procedures now. Back in the dark ages, when I learned them, they had 4. There was a 1 and 1A and 2 and 2A, and that was it. Now there's a whole bunch of them, and probably for the better, because again, these are attempts to more precisely define that distribution environment in the laboratory, and to do so in a fashion that is a recognized test procedure. So they're very handy from that standpoint, and I give them a lot of credit for doing that. It was a heck of a job. Finally, I'd like to point out that the most sustainable package, and by sustainable package I mean the one that's ecologically suitable, is one that is well thought out, uses materials wisely, and is tested correctly. So if you can do that, you're probably, in my opinion anyway, you'd win the sustainability award. You hear a lot of hype about sustainability these days, but in reality, a good, well thought out, well designed and well tested package is definitely the most sustainable one around. While we're on the topic of sustainability, I think it's worth noting that 30% roughly of most municipal landfills are packaging waste. That's in the United States. Now that's actually, even though that number is large, it's an improvement, and it's actually smaller than most people think. If you ask most people how much of that big old landfill, that dump, if you will, is packaging related, most people say, yeah, it must be 60%, 80%, maybe even 90%. The actuality is it's about 30%. Now that's down. It used to be in the neighborhood of 39 to 40%. Most recent studies show it to be about 30% and declining, which is good. But again, most packages are over-designed, as I mentioned earlier, due to the evaluation technique, which is pass-fail, and other factors, political. If, for example, your boss says, you better make doubly sure that that gets there, how are you going to do that? Well, I guess you put 2 films around it rather than 1. Okay, and a lot of that happens. I call those political factors, where people make the decision that it's just more important for me to have a good feel about this, gut feel, than it is to save a couple of cents or even less on my package design. Unfortunately, a lot of that happens. I'm not saying I agree with it, but I'm saying that that's the reality that we live in. So this landfill and sustainability issue may be largely a function of our ability to properly judge how to best evaluate the suitability of a package, and to find out if that function was designed properly, that package was designed properly without over-design or needless waste. I don't offer any magic clues, any golden, golden heroes here, but it has to be done conscientiously in order to make the world a better place and to be more sustainable about it. It's my estimation that that astute packaging could reduce our trash in landfills by an additional 15 to 20%. That's not 15 to 20% of the 30%. That's 15 to 20% of the total amount. But still, it'd be huge. So in my opinion, we owe it to future generations to pursue this with urgency, not just with kind of a wave of the hand and say, oh yes, I have a sustainability check mark on my box here, but to pursue that with urgency. I think we really need that as a society and as a world organization as well. We can't really just think of ourselves as an isolated area anymore. So to conclude, we've tried to tell you about package integrity testing and how those work, but I would like to also make you aware of the fact that this canned procedures, and we mentioned two of them, ASTM and ISTA. There's much more of them as well, but they'll often use the term package performance test standards, so they'll have that word performance in their title. I tend to disagree with that, and whenever I can, I object to it for the reasons stated here, because performance procedures are exactly that. Industry standards are what they are. Looks like there's a question, so Greg, can you let me know what that is?
Sure. We have a question from the audience. I've heard of smart packaging. Is this related to what you're talking about?
Smart packaging might mean a number of different things because the term really hasn't settled in industry-wide. Sometimes smart packaging has to do with packaging that would interact with you. For example, it might tell you the temperature of what's inside. In extreme cases, smart packaging might even be able to do things in response to the environment. For example, if the product gets too cold, it might change colors. There are some smart packaging devices that will tell you if a certain acceleration level has been exceeded, things like that. So there's a wide variety of uses for the term smart packaging, and there isn't any textbook that I've seen, any authoritative standard anyway, that will lead you to that term. So the answer is no. I don't really understand the term smart packaging. I don't think a lot of people do. It's more a function of the marketing of the package, I think, than anything else. So that would be my answer to the question. Let me finish, and then we can open the floor completely for questions here. Again, my final remark is there's no substitute for astute knowledge of the packaging optimization process. Careful design of the product package system, and I do want to emphasize that the product has a great deal to do with its survivability in the distribution environment. It's not just all packaged. These two components, the product and the package, have to work together as a system. That's why you often see those terms plugged in together, product, package, system. It's important to recognize they do work together. And then professional testing of the end result, and I should mention that is exactly what Westpak has dedicated its life to do. We've been in business for 27 years, and that's what we do. Professional testing of this end result. So we're the folks that hopefully can give you a good evaluation of whether or not you've done that job correctly. Okay. So with that as a kind of a conclusion, as my voice diminishes here, I'd like to open this process up for questions. So if there are any questions from the audience, you can submit them as Greg has instructed you, and we'll try to answer them. I should also mention that if questions occur to you later on, if someone says, hey, what did they say about this? And you say, I don't know. You can always submit those questions to us. The email address that you can submit those to is, Greg, could you give it to us?
It is webinar@westpak.com. That's webinar@westpak.com. And we do have a question from the audience, Herb. You mentioned bubble testing. Can bubble testing be done on a 7-foot long pouch?
Good question. And the answer is not only can it be done, but we've done it before. It just requires a container big enough for the pouch? And so the answer is yes. In the medical device business, catheters are noted for being bulky, sometimes long and bulky. And yes, we can do that easily. We've done that before. So yes, it can be done. The procedure requires that you submerge the package 1 inch below the surface of the water and then pressurize it to a level that's predetermined by a procedure in the standard. So the only really requirement is that you're able to submerge it 1 inch below in a bathtub that's 7 feet long. And yes, we can do that. Any other questions?
Yes, we got another question here. Are the resources you recommend for developing expertise in packaging experience? Are there resources you can recommend for developing expertise in packaging experience? So how do people become more familiar with packaging?
Well, two ways. The traditional ones are, you learn about it in school, and I don't want to blow that off because I spent almost 30 years of my life teaching this in colleges around the area, particularly at San Jose State. But that's how you learn the basics, and then the rest of it is simply on the job. And on the job doesn't mean you sit at your desk all the time. It means you're out exploring things. You go to conferences. You go to trade shows. You ask a lot of questions. You become concerned. You basically use the same procedure that you'd learn about anything else. How do you build a boat? You build a boat by sitting behind the desk? Probably not. You go out there and you look at boats, okay, and talk to people who've done it. Same thing with the packaging profession. You go out and you talk to people who've done it. You get active in it. You get involved in the whole process. That's how it's done. I hope that answered the question. Is there any other questions, Greg?
We got another question that just came in. What are the other standards like ASTM or ISTA which can be used for package testing? Are there any other standards out there?
There certainly are. ISTA, International Safe Transit Association, has about 25 or 30 of them in their group, and the ASTM group has published a number of them as well. But there are ISO standards for packaging development. There's EIC standards. Most of these are European. There's Japanese standards. There are a number of Eastern European standards that are now coming on the market. So there's a wide variety of them. Most of them, at least from my reading, tend to be fairly common. And the reason for that is that there's certain elements in the distribution environment, hazards, we call them, and they're common regardless of where you ship them. If you think about it, people are people. Impacts come from people most of the time, and people are people the world around. Some are a little taller or shorter than others, but still, packages are impacted by people. The vibration environment comes from vehicles, and the vehicles are pretty much the same. They roll on wheels, whether they're in China or South Africa or Lord knows where. So there are a lot of commonalities in these procedures, and from my reading, they tend to be pretty much Coke and Pepsi. So if you pass one of the common procedures, you're probably going to be good enough. People do tend to get hung up on procedures and say it's got to be this or that, things like that. There are some regulatory bodies in the U.S. that tend to get hung up on what they call consensus standards. Consensus standards are those who are passed by a committee where no one objects so strenuously that they don't get kicked out of the room or something. But beyond that, most of these procedures are fairly comparable. They may vary a little bit in their intensity levels, but not a lot. So I hope that answers the question. Yes, there are a lot of different standards. Do they vary much? Not very much at all.
Okay, thanks, Herb. We have one more question. Person has a customer that wants to do a monitored ISTA 2A test. Can this be done?
So definitely you could monitor an ISTA 2A test, but it actually depends on your units. So if if you have a pouch and a medical device and you have 10 units in your little box here, we could monitor it, but the results that you get, it might not be consistent, because if you think about it, your pouch on one end might see something different than your pouch on the other end, as opposed to the pouch on the middle. But if you're shipping something like an electronic unit that's just one single unit, with the design package system with like foam, then the answer is definitely yes.
Okay, great. If anybody, go ahead, Herb.
Let me add on to that. This is often done, by the way. A lot of these procedures that I refer to as integrity test procedures are turned into performance test standards by throwing an accelerometer on the product. That's not unusual. The only reason that we tend to be careful about that is that what do you do with the data? That's the important thing. The performance test procedures use a defined a procedure whereby you actually know what data is good and what data is bad. So if you just simply put a transducer on a product and ship it through or subject it to an ISTA 2A test, for example, how do you interpret the results? That's always the problem there, and that's why we don't encourage it. But there's nothing that stops you from doing it. It's just you got to be very careful. Remember, I point out you got to be astute about the process. You can't just generate numbers and think you've done the job. You got to be astute about it. Okay, thank you.
Okay, great. Thanks for the presentation, Herb and Edmund, and thank you everybody for listening. And as we mentioned before, if you missed anything or would like to listen to the webinar again, please check Westpak's website at www.westpak.com under the Events tab. The webinar should be uploaded shortly. We'll also be offering a second session at this webinar at 2 p.m. this afternoon, Pacific time. Yeah. Check our website under the Upcoming Events tab for our next webinar. If you think of any questions after the webinar, please email them to webinar@westpak.com. If there are any other webinars you'd like to see, please also email them to webinar@westpak.com. We will be sending out a survey following the webinar shortly. Please fill it out, as we are always looking to improve the webinars as they come in. Thank you for attending, and make it a great day.